Hello, welcome back to NG Learning, and this is a video for beginning photographers looking at the information that is given about cameras and lenses and how to understand that and the differences between them. So, one of the first and most important pieces of information you may see about a camera body is the sensor size. Okay, and I've shown some here, and we've got a British first class stamp on there for scale. Okay, and a typical DSLR camera is going to be the full frame or APS-C, and you'll see the size of the full frame there is 36mm by 24mm roughly. APS-C is about 2/3 of those dimensions, and that means APS-C lenses can be a bit lighter and smaller, and the sensor size is important because the bigger the sensor, the bigger the photo sites on that sensor, and that means they're generally better at capturing colour and better at capturing low light. So a full frame camera you expect to be a bit better at capturing low light conditions than an APS-C camera. Okay. Another group of cameras is a micro four thirds camera. Again, the bodies and the lenses are a bit smaller than APS-C. Okay. There also exist, if you've got a few £1,000s for just a body, quite a few £1,000s for just a body, medium format digital cameras. Okay, so they have bigger sensors. They're often not optimized for use in low light, despite the fact they've got large sensor sites on them. They're often optimized for getting maximum color information for good landscape photography. Okay, a lot of small compact cameras will have, again, much smaller sensors. If you've got an iPhone or for example Samsung Galaxy or other smartphone, again, it's going to be a bit smaller still. So the smaller sensors can struggle to give you as much definition in low light. So in general, the larger sensor the better. It's not the full picture, but in general the larger sensor the better. Okay, you may also see the number of megapixels of a camera labelled, and that affects two things. Firstly, how big prints you can do from there, and generally the number of megapixels on there is going to be more than you need. So in most cases you don't have to worry about it too much. One thing that is nice about a lot of megapixels is that it lets you crop the images heavily if you want to recompose them afterwards or get certain details out. If I've got a 24 megapixel camera, I can make prints that will stand up to being looked at very closely and still look sharp, of up to 20 by 13 inches. Okay, there's quite a few full frame cameras with 42 megapixel sensors out there now, and I can go a bit bigger. I can go up to about 27 inches by 18 inches, so 2.5 foot across on my pictures. A lot more than most people need, and certainly if you're taking pictures for on screen, that's a lot more than you need. Even actually for on screen, 2 megapixels is generally enough, and that's all you need to make 6 inch by 4 inch prints. For most people, 12 megapixels, even for making enlarged prints, is a good minimum number of megapixels to have, and pretty much any digital camera you buy these days is going to exceed 12 megapixels by quite a long way. So megapixels in general, don't worry about it. Okay, you will also see the maximum ISO listed, and that again is a piece of information you can pretty much ignore, and I'll explain why. So the typical ISOs back in the film days that we would use, an ISO is the sensitivity, so how sensitive our sensor or our film is to light. So we'd use ISO of 100 for shooting in bright conditions. If I was shooting in action shots, or if I was shooting stills in cloudy conditions, maybe ISO 400. Indoors in good light, perhaps ISO 800. And if I was shooting at night, I'd go to ISO 3200. And if I look at a camera like the Sony a7S II, that has a maximum ISO of 409,600. So you can see, in terms of capturing certain conditions, it is far more than we need. However, any camera at its maximum ISO is going to give horrible results. They're going to be blurred or muddy, there's going to be a lot of noise. Okay, so what the important thing is to do with ISO is to work out what ISOs you're likely to want to capture images at, and get some sample pictures, either find online or perhaps go to a camera shop with a memory card, and take pictures under those kind of conditions or at that ISO, and have a good look at the quality of image you're getting at those ISO ratings. So the image you get at the ISO ratings you want to use is far more important than the maximum ISO number. Okay, some cameras are labelled as weather resistant, and that obviously varies quite a bit, and I think it's a good selling point. So it's nice to know that at least they will cope with the odd shower. Okay, some will go a lot further than that. You can submerge some of them in a few meters of water. Generally, if you want to go more than that, you need a proper camera housing to take them further down. But think about what conditions you'll be shooting in and decide how important weatherproofing is to you. Okay, cameras or lenses, depending on the manufacturer, may be labelled with image stabilisation. So some manufacturers like Sony and Pentax have stabilisation in the body, others like Nikon and Canon, the stabilisation is in the lens. And what that does is it will compensate for any shake that happens while you're taking the picture. So normally when you press the shutter button, that creates a tiny vibration, and that can cause blur in your picture, particularly at longer shutter speeds. And it may be labelled as 2 stops, 3 stops, 4 stops of stabilisation. And what that means is if you've got, say, 2 stops of stabilisation, you can take use a shutter speed that's twice as slow, or have an exposure that's twice as long, without losing any sharpness from camera shake. It's not going to do anything to help movement of other objects in your frame, but it will help you take sharp photos of stationary objects in lower light conditions. Okay, the focal length of lenses. So a short focal length, a small number, is a wide angle lens and looks at a wide field of view, and a long focal length or a telephoto looks at a narrow field of view. Okay. Maximum aperture of a lens can be quite important. So the maximum aperture, for example, of this lens is f1.4, and what that means, if as a 50mm lens, the widest gap it can have to let light through into it is 50mm divided by 1.4, which would be a 36mm gap to let light in. So having more light into the camera helps us in 2 ways. Firstly, it lets us create a shallow depth of field, so that's when you've got your subject with blur behind it. And the second thing is getting more light in helps us take good quality pictures in lower light conditions. So a lens with a large maximum aperture, and that means a small aperture number, tends to be better quality and give you more flexibility for isolating your subject and for shooting in low light. Okay, the number of aperture blades is important in some conditions. So as you can see on the left of our image here, that aperture, the size of the gap, is controlled by these blades that are sliding together and causing a small hole in the middle. And because there's only 5 blades here, that means that any out of focus areas of the image, particularly points of light, are going to appear, as we can see on the right, as pentagons. And if I've just got other, rather than points of light, but other aspects of the image that are out of focus, if I've only got 5 blades, it can leave those to look quite messy. So more aperture blades is better, and also where the aperture blades are curved. So just looking at a couple of examples here, we have Canon manufacturer zoom lens, so that means it has a range of focal lengths. So I can go from, in this case, from wide angle to a short telephoto. Now EFS on Canon means it's designed for an APS-C camera, one of those ones with a slightly smaller sensor. An EF lens is designed for a full frame sensor. Okay, so we have our focal length, 18mm being being wide angle, 55 as I said being a short telephoto. The 1:4 to 5.6 is our maximum aperture, and it's got two numbers there because it has different maximum apertures at different focal lengths. So it'll have a maximum aperture of 1 to 4 at 18 millimeters, but 1 to 5.6 at 55 millimeters. Okay, IS on the right means image stabilisation, so it's got stabilisation built into the lens. And STM is a type of motor that's newer and quieter than some of the older ones. And down at the bottom we've got this 58 millimeters, and that refers to the size of screw-in filters that we can attach to the front of that lens. And a Nikon example, so AFS, Nikon, so AF there means it's an autofocus lens. 2470 is wide to short telephoto. Actually it's very similar to the previous one, but this is designed for a full frame camera instead of an APS-C one. VR on there is vibration reduction, which is what Nikon call image stabilisation. So those focal lengths. On full frame, ultra wide, that means it's capturing what can feel an unnaturally wide field of view. That depends on how you use it. It's going to be more than 24 millimeters. Okay, a general wide angle lens that's going to capture a lot, but it's going to look quite natural and undistorted, between 24 and 40 millimeters. A standard lens, which tends to feel quite similar to the field of view we will focus on naturally with our eyes, between 40 and 60 millimeters. And then short telephoto, when we're capturing a narrow view, but it's useful for bringing up things that are further away, and a long telephoto more than 135 mm. And with our APS-C, with our smaller sensor, we actually need slightly wider lenses to do those same jobs. Okay, I hope you found this video helpful. Do subscribe if you want to see future content. Click on like if you like the video, and if you've got any feedback, I'd love to hear from you in the comments. Thank you and goodbye.